This is the final result of an extraordinary journey, a single, perfectly formed chocolate bar, carrying within it disordered chocolate protons. And this is where that journey ends. Seen from above, this facility is a complete and self-contained world, a place where science, engineering, and human skill converge every single day to produce something extraordinary. And with that, the vehicle pulls away. The tractor produced to be around the world is Mavwag's way to this final stage. Wasn't harmitsui to people around the world. Before any vehicle departs, a final dispatch check is carried out to confirm that the product being loaded matches the order specification exactly. All documentation, including certificates of conformity. When a customer order is received, the warehouse management system generates picking instructions and the required pallets are retrieved and staged for loading. It continues every kilometer of the journey. The warehouse management system tracks the precise location and status of every pallet in the facility, using batch identification codes to connect each pallet to its configured or third basis. The system maximizes at the point of sale and is a fundamental principle of responsible food inventory management. Palletized product is transferred to the heat humidity positions. When locus and matrix and call the humidity assessments environment is maintained with the same precision as the production floor. X-ray inspection systems extend the detection capability even further, identifying denser foreign materials such as glass fragments, At critical points along the packaging lines, metal detection and X-ray inspection systems provide an essential layer of consumer safety. Every single unit passes through at least one of these systems before leaving the facility. Sealed and labeled cartons are collected by the robotic palletizing arm, which stacks them onto pallets in a precise, pre-calculated layered pattern. Each layer is arranged to move while the product is in transfer. Every sealed carton passes through an automated labeling machine that applies the production batch code, manufacturing date, and expiration date to its complete production history at any point in the supply chain. On the secondary packaging line, automated case packing machines form flat cardboard blanks into shipping boxes, all without interruption, and all at speeds that manual operations could never sustain. For premium confections and multi-piece products, robotic pick-and-place arms equipped with vision guidance handle the packaging process. These systems can work with products of varying shapeously, consistently, and without fatigue by robotic systems. Every sealed package then passes through an inline checkweigher, which confirms that each unit falls within its specified weight tolerance. Any package food critical both for consumer protection or memory is automatically rejected before it can proceed further along the line. The heat sealing mechanism fuses the packaging film along the bottom and both ends of each bar, creating an air-to-product pressed together contaminations and physical damage throughout its entire shelf life, from the packaging hall to the consumer's hands. Each chocolate bar enters the flow wrapping machine, where a continuous roll of packaging film is precisely folded around it and by the machine's forming guides. The finished chocolate products move from the production area into the packaging hall, where they are prepared for distribution. Packaging in a modern facility is a highly automated operation. Multiple flow wrap traceability records are updated at every stage of the process, linking each finished product batch to its specific raw material lots, processing parameters, and quality test results. Instrumental analysis is complemented by sensory evaluation carried out by trained panel members. These specialists assess the aroma, appearance, and eating quality of finished chocolate samples. Inside the laboratory, sophisticated analytical instruments examine each chocolate sample in detail. Fabri-Tassolol comes part of the batch and the robotic traceability stage all the way through to the finished product. Alongside automated inspection, quality technicians manually collect samples from the production line at regular intervals. These samples are placed into sealed containers and taken to Bidrosargatur quality. The moment a defective product is identified, the rejection gate activates automatically. The non-conforming piece is diverted onto a separate reject lane, while all conforming products continue along the main line completely undisturbed. High-resolution vision system cameras scan the surface of every chocolate bar from multiple angles simultaneously. Bright nadir visicrack, mark, each product and each product fully inspected without slowing the line. Throughout every stage of production, quality control systems operate continuously. In a modern facility, quality monitoring is not a single checkpoint at the end of the line. It is an integrated, ongoing process built in the production system at multiples beneath them. Emerging from the cooling tunnel, each piece carries a fully set, smooth, and glossy chocolate shell. The transformation is complete. What enters from the machine on each piece is the visible result of correctly tempered chocolate, properly applied and precisely cooled. The fully coated pieces now enter the cooling tunnel. The transition from the controlled cold air gradually solidifies the chocolate coating as the pieces move physical temperature change haptorated chamber. Following the chocolate curtain, a set of precisely controlled air jets fires beneath each enrobed piece, removing any excess tormenta piece, the clean, firing finished. This recirculation system is a key component of the factory's efficiency. Every drop of chocolate that drains from the curtain is recovered, filtered, and returned to the dimpbrand for concurrent. As the centerpieces pass through the chocolate curtain, the liquid chocolate flows over, under, and around every surfaces, coating each piece completely and uniformly. The precision flow head of the enrobing machine dispenses a thin, continuous sheet of tempered chocolate across the full width of the belt. This curtain of chocolate is fairly smooth and uniformly as it passes beneath. Not every chocolate product is formed in a mold. Many confections, including chocolate-covered biscuits, caramel centers, nut clusters, and cream-filled pieces, are produced through a Winnowing enrolling. The empty mold trays travel back along the return conveyor toward the warming station and depositing unit at the start of the cycle, where nothing is wasted and every machine operates at its full capacity without interruption. This is the result of an extraordinary journey, one that begins in tropical farms thousands of miles away and ends here in a perfectly formed bar of chocolate. What unfolds inside a modern chocolate factory is a remarkable integration of food science, precision engineering, and continuous quality management. From the moment a raw cacao descends to discover commodity systems, habit, and human expertise. A final dispatch check confirms that the product being loaded matches the order specification and that all documentation, including certificates of conformity and batch records, is in order before the vehicle departs. When a customer order is received, the required pallets are retrieved and staged for loading. Transport vehicles are temperature monitored during transit to ensure the cold chain is maintained from the factory gate to the distribution center or retail customer. The warehouse management system tracks the location and status of every pallet in the facility. The system operates on a first-in, first-out basis, ensuring that older stock is dispatched before newer production, which maximizes product freshness at the point of sale. Palletized product is transferred to the finished goods warehouse, where it is stored under controlled temperature and humidity conditions. Chocolate is sensitive to both heat and moisture, while excessive humidity can on the product's surface. Metal detection and X-ray inspection systems are positioned at critical points on the packaging lines, while X-ray systems can detect denser foreign materials such as glass, stone, and certain plastics. The finished cases are stacked on pallets by robotic palletizing arms, which arrange each layer in a pattern that maximizes stability during transport. Secondary packaging, the process of combining multiple primary units into cartons or cases for shipping, is also handled by automated machinery. Case packers form flat number of prime packs and dates. Multi-piece confections or premium products may be placed into trays or boxes by robotic pick systems equipped with vision guidance. These systems can handle products of varying shapes and orientations, placing each piece into the correct position with high speed and precision. The sealed packages are then passed through an inline checkweigher, which confirms that each unit falls within its specified weight tolerance. Underweight or overweight packages are automatically rejected before proceeding further along the line. Solid chocolate bars typically enter a flow wrapping machine, which feeds a continuous roll of packaging film. The film is folded around each bar, heat sealed, and cut to length, all in a single continuous motion. The finished chocolate products move from the production area into the packaging hall, where they are prepared for distribution. Packaging in a modern facility is a highly automated operation, managed by a series of specialized machines working in coordinated sequence. Traceability records are updated at each stage, linking finished product batches to the specific raw material lots, processing parameters, and their printers. This enables rapid investigation and targeted product withdrawal if a quality issue is ever identified. Any product identified as defective is automatically diverted from the main line before it can reach packaging. Samples are also drawn at regular intervals by quality technicians and taken to the factory's on-site laboratory for physical, chemical, and microbiological testing. Automated inline sensors measure parameters such as chocolate viscosity, temperature, and flow rate at critical points along the process. Vision systems such as Winnowing or road products, any product identified as defective is automatically diverted from the main line before it can reach packaging. Samples are also drawn at regular intervals by quality technicians and taken to the factory's on-site laboratory for physical, chemical, and microbiological testing. Throughout every stage of production, quality control systems operate continuously. In a modern facility, quality monitoring is not a single checkpoint, it is an integrated, ongoing process built into the production system at multiple points. A set of air jets removes excess coating from the base to prevent the formation of feet, unwanted pooling of chocolate beneath the piece. The enrobed products then pass through a cooling tunnel, and by the time they exit, as the centerpieces pass through the curtain, they are completely submerged in and coated by the flowing chocolate. Excess chocolate drains through the mesh belt and is recirculated back to the tempering machine. Centerpieces are placed onto a wire mesh conveyor belt, which carries them through a curtain of flowing tempered chocolate. This curtain is produced by a precision flow head that dispenses a thin, continuous sheet of chocolate across the full width of the belt. Not all chocolate products are formed in molds. Many confections, including chocolate-covered biscuits, caramel centers, nut clusters, and cream-filled pieces, are produced using a process called enrobing, is coated in a layer of liquid chocolate. As the molds exit the cooling tunnel, the chocolate is fully solidified and contracted slightly away from the mold walls and stabilization. The empty molds are then conveyed back to the beginning of the line to be refilled. The filled molds then enter a cooling tunnel, a long, enclosed refrigerated chamber. The temperature is precisely right, and cooling can disrupt crystal formation and result in surface defects. Liquid tempered chocolate is deposited in chocolate contained in each cavity. The filled molds, causing air bubbles trapped within the chocolate to rise and escape, ensuring a void-free, uniform interior. For solid chocolate bars and molded confections, the tempered chocolate is directed into a molding line, one of the most visually striking sections of a chocolate factory, where the liquid chocolate takes on its familiar final shape. A small sample is periodically drawn and tested, a process called a temper test, to verify that crystallization is proceeding correctly before the chocolate moves on to molding or enrobing. The tempering machine cycles the liquid chocolate through a carefully controlled sequence of temperatures. Crystals are cooled to a precise temperature that melts all crystal forms except the stable form Phi crystals. These stable crystals act as seeds, promoting uniform crystallization throughout. Cacao butter is a polymorphic fat, meaning it can solidify into several different crystal structures. Only one of these, known as form Phi, produces a shiny surface and a melting point just below body temperature. Tempering is the process that gives finished chocolate its characteristic snap, gloss, and smooth texture. It is a precise thermal treatment that controls the crystallization behavior of the cacao butter within the chocolate. When conching is complete, the chocolate is a smooth, fluid, aromatic liquid, visually glossy, aromatically complex, and ready to be processed into finished products. Additional cacao butter and liquid lecithin may be introduced at specific points during conching to adjust viscosity to the desired level for the particular product being made. Conching times vary widely. Residual moisture and volatile acids, byproducts of fermentation that can contribute harsh or astringent notes, are driven off during the process. Many flavor steers is rather balanced. The refined chocolate flakes are transferred into large conching machines, enclosed vessels equipped with heavy-duty agitating paddles. These machines work the chocolate continuously, applying mechanical energy that generates heat through friction. The mixed ingredients are blended at controlled temperatures until a uniform homogeneous mass is achieved. This pre-mixed chocolate mass still contains relatively coarse particles and has not yet developed the smooth, refined texture associated with finished chocolate. Conching is one of the most time-intensive and transformatively important steps in chocolate manufacturing. It was first developed in the 19th century and remains essential to producing Conching and their historical counterparts. After passing through the complete roller train, the chocolate emerges as a dry, flaky material. This may seem counter-finished product, be the so try to substrate which is smoothly recognized. As the chocolate mass passes between each set of rollers, the gap between them decreases, progressively crushing and shearing the solid particles within the mixture to an increasingly fine size. The pressure and temperature must be carefully controlled throughout this stage. The mixed chocolate mass is now fed into a series of 5-roll refiners, large industrial machines consisting of 5 horizontally arranged steel rollers that rotate in alternating directions. The mixed ingredients are blended at controlled temperatures until a uniform homogeneous mass is achieved. This pre-mixed chocolate mass still contains relatively coarse particles and has not yet developed the smooth, refined texture associated with finished chocolate. Human operators monitor the process and can intervene if parameters deviate from target values, but the weighing and dosing steps themselves are largely automated, minimizing variability and reducing the risk of error. Ingredient weighing and dosing in a modern factory is handled by automated systems. Precise quantities of each ingredient are discharged from storage silos and tanks according to digital recipes stored in the facility's production management software. With chocolate liquor, cacao butter, and cacao powder all available as separate components, the facility down formulating such as recipes determines the character of the final product. What remains inside the press is a dense, dry cake of compressed cacao solids. This cake is then broken up and ground into fine cacao powder, which will be used in beverage mixes, baked goods, or coatings. The extracted cacao butter is filtered, deodorized if necessary, and stored in temperature-controlled tanks. It will be reintroduced later in the chocolate-making process to adjust texture, mouthfeel, and viscosity in the finished product. The hydraulic press applies thousands of pounds of pressure to the liquor, forcing the liquid fat, the cacao butter, through fine filter screens and out of the press. At this stage, the chocolate liquor reaches a fork in the road. Some of it will proceed directly toward chocolate production. Another portion will be directed into a hydraulic press to separate its 2 primary components, cacao butter and cacao powder. The resulting chocolate liquor is a rich, deeply dark, intensely flavored liquid that flows continuously through insulated pipes. This liquor serves as the foundational ingredient for virtually all chocolate products produced in the facility. From the pre-grinder, the material moves into a series of refinement grinders, often stone mills or bead mills. These machines progressively reduce the particle size of the cacao ball 30 graininess. The nibs are first fed into a pre-grinder, which breaks them down into a coarse paste. Cultural fat content of the nib, cacao butter, begins to liquefy from the heat generated by the grinding process. The cacao nibs now enter the grinding stage, a process that will reduce them from coarse fragments into a smooth, flowing liquid known as cacao mass, or more commonly, chocolate liquor. Despite the name, it contains no alcohol. The result is a batch of clean cacao nibs, small, irregular fragments with Hanserfach flavor. The nibs may be used directly in chocolate production or held briefly in an intermediate storage silo before the next stage. Because the shell fragments are significantly lighter than the dense, fat-rich nibs, the airflow carries the shell pieces upward and into a collection chamber, while the heavier nibs fall downward and continue along the production line. The roasted beans are fed into a winnowing machine, which performs 2 tasks simultaneously, cracking and separation. The beans pass between a series of rollers or impact plates that crack the shell without grinding the nib into powder. After roasting, the outer shell of the cacao bean must be removed. The edible interior of the bean, known as the nib, is what will eventually become chocolate. The shell, by contrast, is fibrous and contributes unwanted bitterness and texture. The aroma released during this phase is unmistakable: warm, nutty, deeply chocolatey, and it signals that the beans have successfully undergone their first major transformation. As the roasting cycle completes, the beans are discharged into a cooling trough, where they are rapidly brought down to ambient temperature. This stops the roasting process precisely at the desired point, locking in the developed flavor compounds. Modern roasters are highly programmable, allowing technicians to set precise time and temperature profiles for each batch. Temperature sensors distributed throughout the chamber relay real-time data to a central system maintaining the temperature profile. Inside the rotating drum, the beans are constantly tumbled to ensure even heat exposure. Roasting temperatures typically range between 120 and 15 to 35 minutes, depending on the desired flavor profile. Raw cacao beans contain hundreds of flavor precursors formed during the fermentation stage that occurs on the farm before shipment. Heat activates these precursors through a process known as the Maillard reaction. Roasting is one of the most critical steps in chocolate manufacturing. It is here that the complex chemical reactions responsible for the rich, characteristic flavor of chocolate begin to develop. Any bean flagged by the system is ejected by a precisely timed jet of compressed air, diverting it away from the main flow. What remains is a clean, visually uniform batch of cacao beans, ready for roasting. Following mechanical cleaning, the beans pass through an optical sorting machine. High-resolution cameras scan each bean at high speed, detecting discoloration, irregular shapes, or surface defects that may indicate internal damage or contamination. The beans themselves pass through the mesh and continue forward along the production line, clean and free of the debris accumulated during harvesting and transport. The cleaning system uses a combination of mechanical vibration, air jets, and mesh screens of varying sizes. Lighter particles are lifted away by the airflow, while heavier foreign objects fall through dedicated rejection chutes. Once released from storage, the cacao beans move into the first active stage of production, cleaning and sorting. The beans are fed into a large vibratory cleaning machine that removes foreign matter, fragments, small stones. Approved beans are cataloged, assigned a batch identification number, and moved into a temperature and humidity-controlled storage area to validates by weight source materials, a critical feature in modern food manufacturing. Only shipments that meet the facility's strict incoming quality standards are cleared for use. Rejected batches are quarantined and returned to the supplier. Bean moisture content is measured using calibrated sensors, since beans with moisture levels that are too high are prone to mold growth, while overly dry beans may crack during processing. These samples are examined visually for signs of mold, insect damage, or fermentation irregularities. The fat content and aroma profile of the beans are also assessed at this stage, as both factors directly influence the flavor of the final product. Before a single bag is opened, the incoming shipment undergoes a rigorous inspection process. Quality control technicians pull samples from multiple points within each delivery. The journey begins not on the factory floor, but at the loading dock. Raw cacao beans arrive at the facility in large or scent burlap sacks, sealed bulk containers. Every day, millions of chocolate bars, truffles, and confections make their way into the hands of people around the world. From the moment raw ingredients arrive at the facility to the second a finished product is sealed and prepared for shipment,